Hi students, this is AJ sir. Let's study 10th standard ICSE Math, Chapter 9A, Matrices, Addition and Subtraction. Exercise 9A, cancel question 1, cancel question 2. Let's do 3.1. This is a matrix and here's another matrix and they're equal. Matrix is an array of numbers or data. Each piece of information is called an element. This matrix has 2 rows and 2 columns. So there are 4 elements and the order is 2 by 2. That is 2 rows and 2 columns. Always rows comes first. If you look at this matrix, it has 2 rows and 3 columns. So the order is 2 into 3. 2 by 3. Make sure there is a lot of space between the elements. If you write them too close to each other, you'll get confused and you'll read this as 21 or 15. In this matrix, there are 9 elements and the order is 3 by 3. When the number of rows and columns are equal, it's called a square matrix. But if they're not equal, it's called a rectangular matrix like this one. 2 rows and 3 columns, 2 by 3. Whereas this is 3 by 2 because 3 rows and 2 columns. So if we have to add these two matrices, it's not possible because the order is not same. Only if the orders are exactly same can we add or subtract matrices. So right now we are going to learn addition and subtraction of matrices in exercise 9A. Multiplication of matrices is a bit more complex and the rules are different, which we shall study in the C exercise in the future. Now any matrix which has only 0 as the elements, it's called a null matrix. That doesn't mean that there are no elements inside. There are 4 elements inside, 4 pieces of data. It's just that the values are 0, 0, 0, 0. That's a null matrix. We can't have an empty matrix. Any matrix in which the diagonal, that is from top left to bottom right, has 1, 1, 1 values, and the rest, all the elements are 0, are called an identity matrix or unit matrix. What is the use of this will be understood when we study multiplication. Transpose of a matrix. Well, what if we convert the rows into columns and the columns into rows? The new matrix that we get is called a transpose. So we had 2, 3, 1 as the first row. So I will write 2, 3, 1 as the first column. 0, 4, 7 was the second row. 0, 4, 7 is the second column. Or you can think like this. 2, 0 is the first column. So 2, 0 is the first row. 3, 4 is the second column. 3, 4 is the second row. 1, 7 is the third column. 1, 7 is the third row. Notice how the order is different. Now this order is 2 by 3 and here the order is 3 by 2. So if we have to add A with AT, that is transpose of A, we can't add or subtract them because the orders are not same. The problem was that it's a rectangular matrix, so obviously the orders will be different. But if it was a square matrix, then even after transposing it, it would have been a square matrix. Then the order would have been the same and we would have been able to add or subtract it. So we will do one such sum. So here clearly the orders are same, that is why they are equal. That means each element is equal to the corresponding one. So minus 4 is equal to B plus 4, A plus 5 is equal to 2, obviously 3 is equal to 3 and 2 is equal to C minus 1. You can compare the LHS and the RHS like that. So let's solve it. If minus 4 is equal to B plus 4, we can get the value of B. If A plus 5 is equal to 2, we can find the value of A. And if 2 is equal to C minus 1, then we can find the value of C. So because the matrices are equal, it means each element has to be equal to the corresponding element. That's the sum. Next, 5.1, 2 and 3. Fourth one can be cancelled. 3 matrices have been given. Orders are same, fortunately. You have to add and subtract them. First we have B plus C. So I write the B matrix plus the C matrix. The data is given in the question. So let's add them. So 1 plus 6 is 7. 4 minus 2 is 2. So that's the answer of B plus C matrix. We get a new matrix. The order of the answer will be same as the individual matrices. In addition and subtraction, the order doesn't change. Second one, A minus C. So I wrote A elements minus C elements. So 2 minus 6 is 4, minus 4, sign of the bigger number. And 5 minus of minus 2, 5 minus of minus 2 will be 5 plus 2, that is 7. So that's the answer, a new matrix of the same order. What is the order? Tell me the order. Do you know how to write the order? Well, it's 2 by 1. Always rows, there are 2 rows, 1 row, second row, and there is 1 column. So rows into column. Don't, not the other way around. Roman number 3, A plus B minus C. So A plus B minus C. 2 plus 1, 3. 3 minus 6 is minus 3. 5 plus 4 is 9. 9 minus minus 2 is plus 2. That's 11. So that's the answer. Next, 6.1 is cancelled. And 6.3. Let's add them. But addition is not possible. The order is not the same. This is 2 by 3. And this is 2 by 2. So it's not possible. So just write addition is not possible because they're not compatible. 6.2 will be for homework, which can be subtracted, but that you can do. Hence I chose to do 6.3 because then I don't have to do anything. 7.2. It's given that this matrix plus this matrix is equal to this one. Find the values of x and y. Okay. If this matrix plus this matrix, how do we add matrices? We add the individual elements, the corresponding elements. So add the first element here with the first element here, I'm getting minus 8 plus y. Add the second element here with the second element here, so I'm getting x minus 2. So I have combined them into a single matrix, which was important because only then can I compare the LHS and the RHS. So now we have 2 elements and here also we have 2 elements. The order here is 1 by 2. Yeah, 1 row and 2 columns. 1 by 2. And here also it's 1 by 2, which was very essential. Only then we can compare and equate the elements of the matrices. What is the use of matrices? Oh boy, it's very important and useful. It's a way to solve quadratic or polynomial equations and functions in higher math. It's useful. It has a lot of practical applications in science and in even other fields. But we don't have applications now. We just have the theory and the rules and regulations of matrices. So just get used to this new kind of math. This is very different from the normal algebra or geometry that you have studied, isn't it? It seems easy now, but the multiplication part is something fascinating. So anyway, the first element is equal to the first element here, so just solve and get the value of y. Second element is equal to the second element here, so solve and get the value of x. That's it. Now the 8th sum. Let's not do the first one. Let's do the second one. So they are saying transpose of m minus m. M's matrix is given. Fortunately, it's a square matrix. That means the transpose of that will also be a square matrix. This is the transpose, by the way. What have I done? I've exchanged the rows and columns. Now they want a subtraction. So transpose of m minus the real m. Notice how the row became a column out here. But the order is same. It's a square matrix, that is why. Hence subtraction is possible here. So 5 minus 5. Minus 2 minus minus 3 is minus 2 plus 3, that is 1, and so on. So the order is 2 by 2. Is this an identity matrix? No, it isn't. If this diagonal was 1 and 1 and 0, 0, then it would be identity matrix. And of course there should be no negative sign either in an identity matrix. Now the 9th one, cancel the C part. Let's do the A and B. They want additive inverse. Additive inverse simply means something which when added to this will give you a zero matrix. A simple trick to write the additive inverse is change the signs. That's it. So if A is 6 and minus 5, it's not 6 minus 5, okay, these are two different elements. There is a gap in between. 6 and minus 5, what is the additive inverse of that? A dash is minus 6 and 5. Just change the signs. Because now if you add A and A dash, you'll get 0, 0. So such a number is called additive inverse. So what is the additive inverse of B? Change all the signs. Minus 2 became 2, 4 became minus 4, minus 1 became 1, and 0 will remain 0 obviously, because 0 plus 0 is 0 and 0 has no sign. Now the 10th sum, 10.1, x plus b is equal to c minus a. The values of b, c and a are already given and the order is same. Good. So no hassles here. This is matrix C, this is matrix A. Now it's like a normal algebra sum. First we shall subtract them. So minus 1, minus 2, minus 3. 4 minus minus 3, 7. So I combine them into a single matrix. Good job. Next, shift it to the RHS because I want x alone. But when you shift it, the plus will become the minus. So subtraction here. So again, let's subtract. Minus 3 minus 0, minus 3. 7 minus 2, 5. So that's the value of x. Done. Now Roman number 2. A minus x is equal to b. Substitute A is matrix, B is matrix. I want x alone. If I shift this here, there's a problem. I'll get minus x. I don't like that. I don't want the minus sign. So I'll shift this to the RHS. It will become plus x. And I'll shift this to the LHS. It will become subtraction. And now just convert it into a single matrix. Minus 1, minus 3 is minus 4. 0 minus 3. 0 minus minus 3 is 3. Be careful with the signs. Don't make silly mistakes. And we get the final answer. So solve it without seeing the final answer and check if you got it right. Hi students, if you found this video useful, press the like button. Also to enroll for my online lectures or online test series, email me or message me on Instagram. Check the description for more information.